In this video, we're going to be talking about one very important concept of reference angles. So first, let's talk about the definition. The definition of reference angles is an angle's reference angle is the size of the smallest acute angle. We call it T prime. So T prime is a reference angle of angle T, formed by the terminal side of the angle T and the horizontal axes. So, for example, here's our circle. If our angle is, let's say, terminal side is here, so the reference angle would be the angle between the terminal side and the x-axis. Okay, so it's the smallest angle. It's always an acute angle. It's always between 0 and 90. Okay, so it will be this one. Now, if you have an angle in a third quadrant, right here, for example, so its reference angle is going to be here. So it's the angle between the terminal side and the x-axis, the smallest angle. Okay. Now, for when your angle is in quadrant 1, then its reference angle is itself, actually, right here. And then for the angle in the fourth quadrant, the reference angle is right here. So it's an acute angle between the terminal side of the angle and the x-axis again. So I hope you guys remember it now. And let's see. What's the next slide? So that's what the next slide is actually showing. Here we have an acute angle in the first quadrant, so the reference angle is itself. And then if the angle is in the second quadrant, then the reference angle is actually, well, it would be this angle, but they are showing it in the first quadrant. So it's kind of like symmetric. It travels to the first quadrant, right? Okay, now for the fourth quadrant, this is the actual angle, and the reference angle is this, and then they flip it to the first quadrant. So the idea is that you can always use angles in the first quadrant, basically, to figure out angles in all of the other quadrants. So that's why they always move it to the first quadrant. So here's the idea. Positive reference angles have terminal sides that lie in the first quadrant and can be used as models for angles in other quadrants. So how are they going to use as models? So here's an example. We have the angle in the second quadrant, right? Now, the point that the terminal side makes with the circumference of the circle has coordinates x, y, right? So cosine x, sine x. I'm going to leave it blank for now. Now we find a reference angle in the first quadrant that's symmetric to this one, right? And we know that its coordinates of this point is xy. Now, since this point is symmetric, so this angle equals to that angle, and the point is symmetric. The only difference is the y is going to be the same, right? The x is going to turn into a negative value. So it's going to be negative x, y. So we could, if we know the x and y coordinates or cosine and sine function of this angle, we automatically know the sine and cosine function of that angle. Okay. Now for angles in the third quadrant, let's say this is our angle, this is our reference angle, which is gonna transfer into the first quadrant right here. Let's say that they're the same, right? They're vertical angles. Now what happens is, again, we can use, it's symmetric. It's symmetric about the origin. So we know the x and y coordinates are going to be similar, just with negative signs. Okay. And then the same happens for the fourth quadrant. We have, if this angle is the same as that angle, again, these coordinates are going to be symmetric about the y-axis. So x is positive and y is negative. So once we know the coordinates of this angle in the first quadrant, then we automatically know the coordinates of the symmetric angles in all the other quadrants. So that's the big picture, the big idea why we're talking about reference angles. Let's move on. So let's first try and find those reference angles. So here it says find the reference angle of 200 and 250 degrees. So first let's draw this angle. Here's my unit circle. And 225, it's bigger than 180. So here's 180. So it's going to be slightly over than 180. Not, it doesn't go all the way to 270, but bigger than 180. Okay, so my terminal side is right here. So my reference angle is going to be this angle right here. Okay, how do I figure it out? Well, we take this whole angle, that's 225, and subtract this portion out. So we take out the 180. So T prime is 225 minus 180. And that gives me 45 degrees. This means that this little angle, if I reflected onto into the first quadrant, is going to be 45 degrees. So between the x-axis and the terminal side here is 45. Okay, so and that's all that they asked, okay, to find the reference angle. So we answered their question, but we also want to answer the question, why did we want to do that? Well, I know that for 45 degrees, the sine is square root of 2 over 2, and the cosine is also square root of 2 over 2, although this is cosine, this is sine. Now, do I know the sine of 225 degrees angle? Well, it's right here, and the sine is the y coordinate, so it's going to be negative, but it is negative square root of 2 over 2. And I can figure out the cosine in a similar manner. So once you know the reference angle, then you know the functions, the sine and cosine of the real angle, the actual angle. And also, if you know sine and cosine, you automatically know secant, cosecant. You also know tangent and cotangent. So once you know those two, then you know all the rest of them. All right, so now I want you to try and find the reference angle of 5 pi over 3. Try it. And if you need a hint, come in later, but I want you to try it yourself first. So pi over 3 is 60, so I have 1, 2, 3, it's 180. 3 times pi over 3 is 180, or pi, right? And then you have 2 more, 1, 2. It's going to be here. That's your hint. This is your 5 pi over 3. It's pi over 3 shy of 2 pi. So if you had a 6 pi over 3, that's 2 pi. Now you have 5 pi over 3, so it's 2 pi minus pi over 3. Okay, so go ahead and finish it. And we're going to move on. So this is actually the same thing that we were talking about earlier, that we have alpha here in the second quadrant, and they're comparing the sine of alpha with the sine of t, the reference angle. So since sine is a y-coordinate, there will be the same. Okay, and for the cosines, since cosine x values, they're on opposite sides of 0, so the cosine t is going to be the opposite of cosine alpha. And then also they're talking about this arrangement when your angle is in the fourth quadrant. So this is beta that's in the fourth quadrant, and its reference angle in the first quadrant, t. So the x values, or the sines, will, oh, I'm sorry, cosines, x values are cosines. Those are going to be the same, right? Cosine t equals cosine beta. But the sine values, which are y coordinates, they're opposite. This one is positive, this one is negative, so sine t equals the opposite of sine b. Okay, so that's actually the same thing we were talking about. And again, this picture just shows different reference angles for different quadrants and how you find it. So if your angle is an acute angle, then you just the reference angle is itself. I decided to zoom in because it was hard to see. Now, if your angle is in the second quadrant, so to find the reference angle, you would take your angle T and subtract 180. Okay, guys, so that slide was kind of difficult to see, so I decided to show you this in the book. So when your angle is in the first quadrant, then your reference angle equals your actual angle. When your angle is in the second quadrant, then you take 180, or pi, and subtract your angle t from it. Now for the angle in the third quadrant, you take your angle and subtract a pi, or 180, from it. And then for the fourth quadrant, you do 2 pi, or 360, minus the angle T. So this is how you do it. This is how you find reference angles. And the last thing that I wanted to show you for this video is basically we projected all of the results from the first quadrant into angles in the second, third, and the fourth quadrant, whose reference angles are 30, 45, and 60 degrees. So now if you notice all of these coordinates, x and y coordinates are corresponding to these coordinates for angles of 30, 45, and 60, but some of them are negative, some of them are positive according to what we were talking about. And again, these are the angles that you should be able to recognize and figure out their trigonometric functions of. And this is the last slide for this video, and in the next video we're gonna do some examples.